Dear students, welcome you in M.K.Jain classes YouTube channel. Here we are going to perform the titration and how we do the titration in the laboratory. So we consider some points how to perform the titration. First of all, we have to know that the titration come in the volumetric analysis. In the volumetric analysis, we perform the titration. In the titration, we calculate the unknown concentration of any substance like KMnO4 or K2Cr2O7. So during the titration, we follow some instructions here. So how we write the titration on the notebook? So first of all, we have to know the main object. In the object, we know that we are going to calculate the molarity or strength or percentage purity of the unknown KMnO4 solution in the titration. So first we write the object, then we write the indicator. Indicator, we know that we are going to perform the KMnO4 titration against ferrous ammonium sulfate. So here KMnO4 itself is a self indicator. Now next point related with the apparatus. Apparatus in the titration we use burette, pipette, funnel, conical flask, beaker, etc. Now next we consider the chemical equation which we are going to know in the next slide. Chemical reaction. In the chemical reaction, we know that KMnO4 is act as a oxidizing agent and ferrous ammonium sulfate act as a reducing agent. The chemical equation or reaction related with ionic equation also. Then after the ionic equation, we know that KMnO4 is write as MnO4 negative converts into Mn2 positive by getting the 5 electron. Now during this reaction, here we have the 4 hydrogens, so we balance it with the water, 4 water, and we required 8 H positive ion. So this is the ionic equation for KMnO4 solution. The next, the ferrous ammonium sulfate converts into the ferric ion by losing the electron. So this is the ionic equation for the KMnO4 and ferrous ammonium sulfate titration. So after writing this ionic equation, we have to write or consider the observation table. And in the observation table, we write the reading of the burette and what volume we consider in the pipette. We have to all the things we write in the observation table. So in the observation table, we write about the unknown KMnO4, and known concentration of ferrous ammonium sulfate. We know about this all thing in the observation table and write all the reading in the observation table and use this observation table for the calculation. So in the calculation, we consider the molarity equation M1V1 is equal to M2V2. But here we are using the KMnO4 against ferrous ammonium sulfate. So we write the 5 over here. So this is related with the calculation. Here we know about the M2, the molarity of unknown solution, that is the KMnO4. Then in the last we have to write the result. Result is the must, and in the result we write what we know after the calculation during the titration. Now let's start the practical, how we perform it. So I consider or I bring some instrument from here. First of all, this is the burette stand. This burette stand has clip over here, so we fix the burette in this clip. This is the burette, and this burette has marking itself. So here marking is from 0 to 50 ml. Okay, now burette has one nozzle over here. This nozzle is right now it is closed, but we can open it by in this way. Okay, so we close it and we fix it on the stand. Now while fixing the burette, make sure that numbering comes in front of you, so you can consider the number which we are going to calculate. Okay, now next is the pipette. Here this pipette has marking 20 ml. So we use this pipette to pipette out the known concentration of ferrous ammonium sulfate. Now next, be careful while keeping the burette on the table. Now next we use the funnel. Here this is the funnel. The funnel is placed over this burette. So we fill the KMnO4 solution. Now KMnO4 solution, we take it all. I already prepared this KMnO4 solution. This is the unknown concentration KMnO4 solution, potassium permanganate. So we fill this potassium permanganate in the burette very slowly. Now by filling the burette, remove the funnel first and then decant some KMnO4 to get the 0 point. Now very slowly, drop wise. Now the burette is on 0 marking. Now our burette is ready for the titration. So I keep this KMnO4 next to my burette stand. Now I bring my ferrous ammonium sulfate solution. This ferrous ammonium sulfate solution which I already prepared, and this is the known concentration. So I pipette out this ferrous ammonium sulfate by using this pipette. So I also need conical flask. So I have one conical flask. This is already washed. Okay, so I pipette out this ferrous ammonium sulfate. Now I use my index finger to stop this solution. So this pipette is 20 ml. Now I am filling this 20 ml in or pour in this conical flask. The solution is going automatically into the flask. Make sure that all solution fill in the conical flask and keep this pipette side of your stand. Now we have to pour one test tube of sulfuric acid to stop the oxidation of ferrous into the ferric ion. So I use test tube and dilute sulfuric acid to pour inside. Now here I have a sulfuric acid, dilute sulfuric acid and test tube. So I fill this test tube with the sulfuric acid and pour the sulfuric acid in the ferrous ammonium sulfate. Now my solution is ready for the titration. So this is the KMnO4 which concentration is unknown, and in this conical flask ferrous ammonium sulfate along with sulfuric acid. Now for the titration, make sure that you are keeping the nozzle directly into the conical flask like this way, and then open the nozzle very slowly to pour the liquid dropwise and shake the liquid properly for the mixing. Now see that the pink color appear and disappear. So my process is going on. The reaction is not complete over here. So now see the changes appear in the conical flask. The solution turns white to pink, colorless to pink in color. Now see this color very clearly. It is a very tinge of color, pink color. So this indicates the completion of the reaction. So now for this titration, I am showing you the slide over here. So in the slide, the object is written over here. So see this slide. Our aim is to find out the concentration of given KMnO4 solution in gram per liter. For this purpose, you are provided a standard solution of crystalline ferrous ammonium sulfate of M by 30. The M by 30 is the known concentration of ferrous ammonium sulfate. Now, what we required over here, the instruments are written here: burette, pipette, conical flask, and funnel, etc. Now, next is the chemical required. The chemical which are used over here, the potassium permanganate filled in the burette, and ferrous ammonium sulfate, which is colorless, transparent in the ferrous ammonium sulfate. Now this solution we use over here along with this dilute sulfuric acid, which we pour inside the conical flask. Now the indicator is KMnO4, which act as a self indicator. This KMnO4 turn the solution color colorless to pink in color. Now see the next slide. In the next slide, you can see that theory is the must to write. The theory indicates that the molecular formula of the ferrous ammonium sulfate, which is called more salt, is written here: FeSO4 NH4 whole twice SO4 and 6H2O. This is the molecular formula of ferrous ammonium sulfate. Now this is the redox titration. Why? Because KMnO4 is an oxidizing agent and ferrous ammonium sulfate is a reducing agent. Now during this titration, the KMnO4 oxidizes ferrous into ferric ion when pink color obtained at the end point. We can see this pink color in the conical flask also. So now dear students, come to the next slide. Now in the next slide, you can see that chemical reaction is written over here. You can see while balancing the reaction, we get 2 mole of KMnO4 that is used and it acts as an oxidizing agent. So we can say 2 mole of potassium permanganate is used to oxidize 10 mole of ferrous ammonium sulfate. This is the main reaction. Then we can write the ionic equation also. We have to write the ionic equation. So we write that how KMnO4 converts the ferrous into ferric ion. So we indicate that this is the reduction and this is the oxidation process. So this reaction is a redox titration reactions. Now come to the next slide. In our next slide, as we know that the reaction is complete over here, so I have some reading in the burette. The burette reading I have to read from the front side, so marking is clear over here. So this marking is around, which I write here. The first reading was 20.1, that is the rough reading. The rough reading always write in the first serial number. Now we get the 2 Concord reading, that is the 19.9. So we perform this experiment 3 times. All 3 times we fill the burette till the 0, then fill this conical flask with the ferrous ammonium sulfate along with sulfuric acid. So 3 times we perform this practical and we get this one numbers or digits. Now in this observation table, this clear that it is a titration between ferrous ammonium sulfate and KMnO4. So the volume of the ferrous ammonium sulfate which I have taken in from the pipette The pipette mark is 20 ml. So I write here 20 ml. So we perform 3 times. So 20 ml I write here 3 times. Then the burette reading, initial reading means burette completely filled till the 0. So I write the initial reading 0. Okay, 3 times 0, 0, 0. Then I perform 3 times practical. So 3 times I get the different reading, but 2 readings, the last reading must be same, because this same reading indicate you the perfect titration process. So I get this reading. This is called the burette reading, which is we get from the burette. Now this reading belongs to KMNO4, so I write here KMNO4, and all reading comes in the ml or milliliter. Now the same reading which I get here, I write in the concorded reading in ml. So this concorded reading is very helpful in the calculation, which I show you in the next slide. So see the next slide. Here I perform the calculation. This calculation belongs to the calculation of the molarity of KMNO4, the KMNO4 that I filled in the burette. So this concentration is unknown, so I write here unknown. Now I use the molarity equation. This molarity equation is the M1V1 is equal to 5M2V2. 5, already I told you that we use the 5 mole of this ferrous ammonium sulfate and 2 moles KMNO4. So I know this molarity. So I write the equation over here. Now in this equation I write M1, that is the molarity of known ferrous ammonium sulfate, which is given in the object exercise or aim or in the question. So I write M by 30 over here, which already have given to us. Now V1 is the volume of ferrous ammonium sulfate, that is the pipette reading, that is the 20 ml only. Okay. Now M2 means the molarity of KMNO4, that is unknown for us. So I write the question mark over here. Now next is V2. V2 means the volume of KMNO4 that is used during the titration. So I get this reading through the burette. So that reading comes, concorded reading is 19.9 milliliter. So I use this all values put into the formula, and my formula become like this. So here I know the M2. This formula I use to calculate the strength of the KMNO4 solution. So how we get the strength? The strength we get by the molarity multiply with the molar mass. So with this experiment we perform with the potassium permanganate. So potassium permanganate, the molecular mass of the potassium permanganate is 158 gram per liter. So the molarity, this molarity I calculated here by using the observation table. So I put all this value in this molarity and multiply it with the molar mass of the KMNO4. So I get this reading, last reading. This is the answer, the strength of the KMNO4, that is the 1.0586 gram per liter. Okay. Now you make sure that while calculating this titration, we have to get the 4 digits number after the decimal point, because it is must for the numbering. So I get this answer in the gram per liter. My exercise is this one. So what I know the strength of the KMNO4 solution from here. So I write the result, last result. We have to mark the result. Okay. If you not write the result, then you may lose the number also. So you have to write in the result the strength of given unknown KMNO4 solution that I calculated 1.0586 gram per liter. This is the unit. Okay. So we have to write all things properly. We have to perform the practical very performly and make sure that all things are right, very neat and clean way. Don't do any mistake, don't mark any cross, don't cancel anything. Okay. So you write very neat and clean way. So I think this video is very helpful for you. So please, for the M.K.Jain classes, you like, share and subscribe the channel. Thank you.